Hi all, today I am going to discuss on the topic extension of ammeter and voltmeter range. I am talking about the PMC type ammeter and PMC type voltmeter. So in case of measuring instrument, it has certain measuring range and the instrument cannot be used beyond its limits, maximum limit. Now question is that how we can increase or how we can extend the range of the ammeter and voltmeter. When the PMC type instrument is used as an ammeter, its range can be extended with the help of a low resistance shunt. In the figure, this is the ammeter, and across the ammeter, a low resistance is connected so that major portion of the current is flowing through the shunt resistance and only the full scale deflection current is flowing through the meter. Here, I is the main current which is to be measured. So Im is the full scale deflection current. I minus Im is actually the shunt resistance current. Now, how we can calculate the value of shunt resistance to measure a required value of the current. Here, shunt resistance is the RSH, Rm is the coil resistance of the meter, Im is the meter resistance which is equal to the full scale deflection current. ISA is the shunt current which is flowing through the shunt resistance. I is the current to be measured. This is the main current which we are going to measure. So, as shunt resistance and meter are connected in parallel, the voltage drop across the shunt resistance and meters are equal. So voltage drop across the shunt resistance will be ISH into RSH and voltage drop across the meter is IMRM. By equating these two voltage ISH RSH equal to IMRM and I equal to ISH plus IM. I is the main current, I equal to, you can write I equal to ISH plus IM or ISH equal to I minus IM. So from this first equation we can write RSH equal to Im by ISH into Rm. In place of ISH we can write I minus Im. So RSH equal to I by I minus Im into Rm. So by using this equation we can calculate the required value of RSH. We know the value of full scale deflection current of the meter and we also know what we are going to measure, I, and Rm is known. So by putting all this value we can calculate the value of RSH. Now how we can extend the voltmeter range? To extend the range of voltmeter we have to connect a high resistance in series with the meter. Here the high value of resistance is known as the multiplier resistance. Higher value of resistance is connected in series so that only the full scale deflection current is flowing through the meter. Here in this circuit we can say the supply voltage which we are going to measure is divided among the meter and the multiplier resistance. Now how we can calculate the value of multiplier resistance? Here RSC is the multiplier resistance, Rm is the meter resistance, Im equal to IFS is the full scale deflection current. Small v is the voltage drop across the meter and capital V is the voltage to be measured. So voltage drop across the meter is small v is equal to IMRM and the capital V is the supply voltage which is to be measured. Capital V equal to voltage drop across the meter plus voltage drop across the multiplier resistance. So capital V we can write capital V equal to Im into Rm plus RAC. Therefore RAC equal to V minus Im Rm by Im equal to V by Im minus Rm. Now the multiplier factor is defined as m equal to capital V by small v. This multiplier factor actually denotes the ratio of the voltage which is to be measured divided by the voltage drop across the meter, and that is equal to Im into Rm plus Rsa divided by Rm Im, and it is calculated as 1 plus Rac by Rm. Therefore, R is equal to M minus 1 into Rm. Sensitivity of PM system instrument. Moving coil instruments is very sensitive instrument, and it is therefore used to measure current and voltage with high value of sensitivity. The coil of the instrument may require a small amount of current for a full-scale reflection of the pointer or of the meter. The sensitivity is expressed in ohm per volt, and it is defined as S equal to total voltmeter resistance in ohm divided by full-scale reading in volts. S equal to Rm by small v. Rm is the meter resistance and V is the full-scale reading in volts. So S equal to 1 by IFS, and unit is ohm per volt. Here IFS is the full-scale deflecting current. So the sensitivity depends upon the current to give full-scale deflection.